Hello. In this video, I will provide a brief introduction to STATA software and its most important commands and functions. But first, we need to know the interface of STATA. This interface contains several boxes and is more or less identical in all versions. The first box on the top right is the variables box. In this box, we will see the names of the variables in our dataset and their labels. The second box, which is just below the variables box, is the properties box. In this box, more information is provided about the variables and the data. In the top section of this box, the information about the variables is provided, and in the bottom part of it, information about the data itself, including the number of observations, is provided. The box in the middle is called the results box and is where we will see the results of our analysis. Below this box is the command box, which is used for writing commands for analysis. In STATA, like our software, we can write the commands for analysis instead of the click-based option. In the left, we have the history box that will show the commands that we have used in the session. The second part of the interface are the tabs. In the File tab, we can open existing datasets, import data from other file formats, and export our data. The Edits tab is not important. The Data tab is for describing data, editing our dataset, or observing it, creating or changing variables, and cleaning our dataset. The Graphics tab is for when we want to use different templates for creating charts. The Statistics tab is where we will find the analysis, and in Help we can acquire more info about the STATA commands and functions. In STATA, we also have some shortcuts shown here. This shortcut is for opening data, this one is for saving, this one is for printing the results, this one is for logging, this one is for adding new viewers, this one is for graph being brought to the window. STATA will open graphs in a different window every time we perform analysis. This is for opening a new do file. This shortcut is for editing the data. This shortcut is for observing the data, and this one is for variable manager. Now we're ready to enter some data. The easiest way to enter data is inserting data in an Excel file and importing it to STATA, so first we will cover that one. To import data from an Excel file, we will go to Files tab and come to Import and choose Excel Spreadsheet. Here we will choose the Excel file that we have entered the data in. Then, if in the Excel file we have entered the variable names in the first row of the dataset, we need to click on Import First Row as Variable Names. With this option, the STATA will read these names and place them on its variable names. In the preview section, you can see the effect of this option. We can also choose to only import a specific range of data. From here, This option is really useful if you want certain variables and not to import the whole dataset, or if you want a certain number of observations, like if you only want the data of the last year and not all years to be analyzed, and you don't need the whole thing to be imported. Now we are done, so I will click OK. As you can see, in the variables box, the names of the variables in the dataset has appeared. Now we'll go to the dataset from Data Editor Browse shortcut to show you the data that was imported. Now if you insist on entering data in STATA, first we need to create the variables one by one. To do this, there are several ways. The first one is to go to Data tab, come to Create or Change Data, and choose Create New Variable. In the window, we will write the name of the variable. For instance, I will write height as the name of the variable, and I will choose Fill with Missing Data, as I want to enter the data manually. The above option, which is called Specify a Value or an expression, is used for when we want to do different things, like creating a new variable from existing variables. I will cover this later. In position of new variable, we can choose where this variable will be placed in our dataset. For instance, it can be inserted at the end of the dataset, or before or after a specified variable. The second and third option, when choose, you need to specify which variable you are referring to. Here I will press OK, and as you can see, the name of the variable is shown here. And if I come to Data Editor Edit, I can enter the data manually. The second way is to write this command: generate the variable name equals dot. Of course, I've already made a variable called height, so I will add height 2 here. As you can see, now I have created height 2, which I can now fill with the missing data. We can also write the command dbGenerate. This command will open the dialog box for generate function. A side note is that db, which is short for dialog box, works for any package that has a dialog box and can be used as a shortcut for opening the dialog box of interest and using the click-based options. Here I can write name the same way I did before, and click OK, and this variable will be made. If you are already in the data editor window, you can also go to an empty column, click on its cells, and enter the data. Now the software will give this column a name, bar3. For instance, you will choose the column and then come to the Properties tab, and here under Variables Name, you can change the name and then press Enter, and as you can see, the name of the variable has changed. If we want to create a variable from performing calculations on one or more variables, we will open the dialog box of generate as previously described. We will write the name of this variable and set its location in the datasets, and then come to contents of variables and choose specify a value or an expression, and then click on create. This will open the expression builder window and provides us with an array of functions. In the example, I have created a dataset with three variables: patient ID, height in meters, and weight in kilograms for each individual. And I want to calculate the BMI for each individual. To do this, I will need to divide each individual's weight in kilograms by the square of their height in meters. So I will create this expression by coming to Expression Builder, selecting Variables. Now I can see the list of variables I have. I will click on the variables so their names will come to this tab, and then use either my mouse or keyboard to build the expression that I want. And as you can see, the BMI variable has been created and it has been calculated by the formula specified. I can also directly calculate this without opening the generate box by just typing this formula in the command. And it will generate the same thing. Now let's discuss the history box. This box will keep the records of the commands you have performed in this session. If you come to a command in your history box and right-click on it, you can choose to either copy, cut, delete, do, or save that command. However, if you left-click on the command, it will appear in your commands box. I recommend left-clicking for editing the command in situations like if you want to perform the command on a new variable, or if you want to modify the command like changing the analysis method used in the command. To clear your command history box, just come to the command history box and click on any of the commands, then push Ctrl A and press delete. To clear your dataset, write clear and press enter. As you can see, this dropped all of the variables in the dataset. Another important command is the drop command, followed by the name of a variable that I want to delete from my dataset. If I push enter, this variable, as you can see, will be dropped from the dataset. Another option is to use keep command, followed by name of the variable that I want to keep in my dataset. With this option, only the variables that I specify in the command will remain in the dataset. The drop option is useful for situations where I want to delete a few variables, and the keep command is useful in datasets that I want to only keep a handful of variables and delete many variables. For the next section of the video, which is dedicated to drawing graphs, I will first show you the dataset that I have created for this example. This dataset contains three variables: the dependent variable slash outcome, which is each individual's speed. This is a continuous variable, the ID of each individual, and one independent variable, which I've named diet. This is a categorical variable numbered 1 to 4, with each individual's different diet being coded as 1, 2, 3, or 4. This way of building your dataset is suitable for the majority of the analysis. Since my dependent variable is continuous, I will choose a scatter plot. To do this, I will come to Graphics tab, choose Two-Way Graph, and choose Create. Now in Basic Plots, in the Select Type, I can choose a scatter plot. Under Plot Type, I will choose my variable that I want to be placed on the y-axis here, and choose the variable being put on the x-axis here, and then click Accept. Now I'm ready to choose OK, and this will create the plot. But before I do that, I want to show you a few other features. If you come to the y-axis tab, you can modify the title of the axis here. This can also be done for the x-axis in the next tab. If you come to overall, you can change the settings for the size of the graph and its name, shown here, here, and here. And the option by can be used to draw subgraphs for each subgroup. But first, let's show you the graph for the original data. So I will push OK, and this will create the plot. One important thing is that STATA can't have multiple graphs, so each time you build a new graph, the previous graph will be deleted. Therefore, you need to save each graph before building new graphs. That can be done from here and choosing Save or Save As. The Save option will save the graph as a STATA graph, and in Save As you can choose to save the graph as PDF or JPG. To create subgraphs for a third variable, I will do the previously described steps, then come to the tab by and choose Draw Subgraphs for unique values of variable. Here I will choose the variable, which is a new variable called height category, with 1 being short, 2 being average, and 3 being tall. Now I will choose OK, and as you can see, for each subgroup a separate graph was built. After a graph is created, we can edit it by either going to the tab Files and choose Start Graph Editor or through its shortcut here. Now Graph Editor is activated. For instance, we can come to Tools and choose Add Text to add the text box where we want. Now I will click here and type the text that I want. I can manipulate its size and color, and as you can see, it appeared here in the graph. In another example, by coming to the tab Graph and choosing Legend properties, I can manipulate the legends. For instance, I can change their sizes. I can also come to title and type the title that I want for the graph. This will add a title to the graph, as you can see, which is shown here. You can also change the colors of different graph properties or resize the fonts. For instance, by choosing properties for my title, I can change its size. For instance, I open it to be huge and choose the red color. And as you can see, the title of the graph is now bigger and red. To calculate descriptive analysis, we will come to Statistics tab, choose Summaries, Tables, and Tests, and come to Summary and Descriptive Statistics. In this example, I want to calculate the mean for my speed variable, so I will choose mean and choose the variable speed here. I can calculate this by each subgroup, which would be the diet here. However, if I want to calculate the mean for the whole population, I would leave this box empty. In the reporting tab, I can change the level of confidence or choose the decimal format and other options here in the set table formats. I don't want to add any other changes, so I will click OK, and as you can see, the mean of the variable speed was calculated based on each group of the diet variable. However, one important note is that if my data was from survey, I would need to first declare the data. For declaring the data as survey data, I will have to come to Statistics and come to Survey Data Analysis, and in Setup and Utilities, choose either declare survey design or survey data, and here add the variable. My data is not from a survey, so I will not do this. For the table that STATA created, I can do two things: either select the whole thing and copy it as a picture, or less useful is to copy it as a HTML, or just take the values for each column and row with this option. For analytical statistics, however, we have several options. If we go to statistics, summaries, tables, and tests, we will see the classical tests of hypothesis, which are t-test, z-test, binomial probability, and test for proportions. We also have the nonparametric tests of hypothesis right under the classical tests. In STATA, the tests are also categorized based on the type of the dependent variable / outcome. For instance, my dependent variable speed is continuous, while I only have one independent variable which is categorical with 4 categories. For this data, I can do a one-way ANOVA. Or perform a linear regression or a generalized linear model, which are shown in the picture. In STATA, we have do files. These files are used to store commands. Their format is .do. To make these files, you can click on the shortcut New Do File Editor. This will create the do file. Now you can write the commands that you want to store. You can also directly send commands from the commands history box by right-clicking on the command and choosing Send Selected to Do File Editor. Another function of the do files is that you can directly execute them by going to Tools and choosing Execute from top. This option will execute all the commands in the do file from top to bottom. In order to save your do file, you will need to just push Ctrl S and save it. After saving the do file, you can open it from File tab and Open section just like any other STATA file. You can add notes to your do file, like notes explaining each command. To do this, after opening the do file, enter a new line and push 2 asterisks and then type the note. The STATA will ignore these lines when executing the do file. Although some packages are already installed in STATA, there are some other packages which were written by STATA community. To know which packages are already installed on your STATA, you can type the command adder here. This will write the list of the packages that are installed on your device. You can also use the command adder uninstall followed by the name of the package to uninstall that package. However, uninstalling packages is not necessary, so I don't recommend it. To install a new package, you can either search its name using search command and followed by the name of the package and download the related files, or write ssc install followed by the name of the package. To see the list of the packages available in STATA, we can write the command ssc describe followed by an alphabet. I am not at the moment connected to the internet, so it's not going to show the list. This option will show all the packages starting with the letter A. SSC new can be used to know about the packages that are most recently added or updated. SSC hot can be used to know about the packages that are the most popular at SSC, and SSC describe followed by the name of a package will provide you with more descriptions about the package. Typing help followed by the name of the package or command will provide you with more explanations about those commands or packages. As you can see, I was going to look at the NW cluster and it opened the help part for it. To learn more about each command, you can use STATA User's Guide Manual. This manual is available for each version of STATA. Another way is to subscribe and like this video, as I also provide more information about these commands in STATA. Thank you for watching.